All right, my AP loves. So I got this little whiteboard here, so I'm hoping that it'll work good for us while I'm lecturing from home. But I wanted to give you guys some of just the basic genetic vocab that you guys are going to be using in Unit 5 Part 2. So that way you kind of get your brain jogged, get you remembering everything that you guys have done before. So some of the basic vocabulary you guys need to know. For sure, definitely what a genotype is. And it is right here. And a genotype is the actual alleles. Well, what is an allele, you might ask? Well, let me tell you. So an allele is a different form of a gene. So two alleles make up a trait, okay? So you get one for mom and one for dad. So here, the big A, we have homozygous dominant. And these are just an example of you can have. So I have over here, you can have homozygous dominant, which is two capitals, because dominant is uppercase. You guys should know that, but let me go ahead and put this on here. It is uppercase. And then we have homozygous recessive. And homozygous recessive is two lower cases. So homozygous right there means that they are the same. And dominant is going to be the uppercase, and then the recessive is going to be the lowercase. The last one that we can have is heterozygous, which are different forms of allele. So you have one upper and one lower. There is no dominant or recessive. It is just heterozygous. So the phenotype, which is definitely a term you guys need to know, is the physical appearance of something. So if we're talking about a red plant or a yellow plant, that would be the actual phenotype. So genotype will determine the phenotype. And I will go into that in our next little mini lecture that I will have to erase my board, and I will pause here, and I will see you guys in just a few. All right, two more words that you guys need to know is what a purebred is and hybrid. A purebred is just anything homozygous. So I put the two alleles to give you guys an example. So big A, which is homozygous dominant, or little a, which is homozygous recessive. Hybrid is different, so it's heterozygous. So a lot of times, I know you guys have seen Punnett squares before, multiple times probably, 7th grade and a lot in middle school. But they'll have you cross things like this right here. So let's just do big A, which is homozygous dominant to homozygous recessive. Like I said, this is a refresher for my AP peeps, because sometimes we just have to refresh our memory on how to do the things we have not done in so long. So we bring this little A over here, we bring this one down, and so forth and so forth. So if you cross two purebreds, which is homozygous dominant to homozygous recessive, you will always yield 4 hybrids. Okay, so your possible offspring are these 4 inside here, and they are all hybrids. All right, so we are now going to practice a couple of Punnett squares, and then that will be all for the basic genetic practice one. So Gregor Mendel is the father of genetics, and he studied pea plants because he had a very exciting life as a monk. And he studied thousands and thousands of pea plants. So he studied the texture, the round or the wrinkle, which we're going to be working with. He studied the color, if they could be green or yellow, and he observed traits that could be passed down. So it's kind of cool. So we're just going to be working with, like I said, basic Punnett squares, and kind of looking at some where genotype, phenotypes being pulled out, so you guys just have a refresher. So the first square that we're going to do is homozygous dominant with homozygous recessive. So I have the big R is round and little r is wrinkled. So homozygous dominant, homozygous means same. Dominant is uppercase. And then I want homozygous recessive, which is the same, and they are both little. So let's do our Punnett square here. All right, so if we cross two purebreds, so this is going to be the parent generation, we get all hybrids. So the genotypes within our Punnett square for this one, we are going to have 4 or 100%, however you want to write it, heterozygous. And they're all going to be round because they all have the dominant allele. And the dominant allele is your uppercase. So that is why in my previous amazingness on that I had on my little mini board here, I said that genotype determines phenotype, and that is because if it shows a dominant trait in basic Mendelian genetics, then the dominant trait will show, the dominant allele will show the dominant trait. So here, for the phenotypes, we will have 4 round. Sweet, that problem is done. So the next one, I want you to cross the F1 which are these little dudes in here from the previous problem, so we can do another Punnett square. So we are going to cross two hybrids, so big R, big R. So let's get that Punnett square rocking here. Sorry for my board. I have it up not very well right now. So let's fill in this. So now it's a little different. We have some different options. So our genotypes here, I have one big R, and I have two big R little, and one little little. I'll move over here to this close here. And for the phenotypes, I'm actually going to have 3 round and 1 wrinkled, because we have 3 that are going to show the dominant allele.
Can I try something?
And that is JJ. He is my mini helper in my lecture. So anytime that you cross 2 hybrids, which is an F1 population, or excuse me, F1 generation, which is right here, and this is your F2, that's here, so your 0 genotypes, your F2. But anytime you cross 2 hybrids together, you will always, in the genotypes right here, get a 1-to-1 ratio. And for the phenotypes, you will get a 3-1 ratio. Let me repeat that. So when we do 2 purebreds, we yield 100% hetero, with 100% showing the dominant trait. When we cross 2 heteros together, we are getting a 1-to-1 genotypic ratio and a 3-to-1 phenotypic ratio. And I think that is all for the day. So thank you for listening to our amazing basic genetic vocab lecture. JJ, anything you got to say?
Yeah.
There you have it, folks. Love you guys. Hope to see you soon.